Find the vertical asymptotes of f of x equals the quantity x minus 4 over the quantity x squared plus x minus 6. The first step in finding the vertical asymptote is to find the zeros in the denominator. So we set the denominator equal to 0. This is a quadratic, so we're going to factor this. We're looking for two numbers such that when we multiply them, we get -6, and when we add, we get +1. And the candidates are 3 and 2. 3 times -2 is -6, and 3 plus -2 is 1. We can double check this by multiplying this in. X times x is x squared, x times -2 is -2x, -2x plus 3x is +1x, and then 3 times -2 is -6. Make sure you double check your factor. Right? So we use the zero product property to set each of the factor equal to 0. We get x equals -3 and x equals 2. And so potentially there are two vertical asymptotes, but that is not enough. Next, we would need to check the limit at each of the 0. And we only need to check the one-sided limit. So at x equals to -3, let's find the limit on the left. It doesn't matter whether we find the limit on the left and on the right-hand side. Now, this is the limit at x equals to -3. Now, f of x is x squared minus 4 over x squared plus x minus 6. And so we factor both the numerator and the denominator. X squared minus 4 is x minus 2 times x plus 2. It is a difference of two squares, so it is the product of the conjugate, and we factored the denominator already, x plus 3, x minus 2. We can cancel out the factor x minus 2, and so we end up with the limit at x equals to -3 on the left-hand side of x plus 2 over x plus 3. Now we're going to argue this limit using the small and large numbers properties. Think of a number that is on the left-hand side of -3, and so this number can be -3.000001 on the left-hand side of -3. If we plug in this number into x, we end up with a number that is very close to -1, -3.0001 plus 2. And if we plug in -3.0001 into x in the denominator, plus 3, we would end up with a very small number, and it is negative. And so we have a -1 over a negative very small number. So the result is positive very large number. Negative divided by a negative, and a finite number over a very small number is a very large number. We denote a very large number infinity. So that means that we have a vertical asymptote at x equals -3. We also need to check the other zeros, x equals to 2. This time, we also want to take a look at the left-hand side limit. And again, it doesn't matter whether we check the left or the right-hand side limits. As long as the limit is positive or negative infinity, then we would end up with a vertical asymptote. We already simplified the numerator and the denominator, so we would end up with this. As we take x approach 2 on the left, the numerator approach 4, and as we take x go to 2 from the left, the denominator approaches 5. And so this expression is 4 over 5, which is clearly not a very large number. And so we do not have the vertical asymptote at x equals 2. To recap, we have a vertical asymptote at x equals -3 only. When we write the vertical asymptote, we need to write x equals.